Alright, in this lesson we're going to graph inequalities on a coordinate plane. So a couple things to remember when we're graphing inequalities is how we graph our boundary lines and which side we shade on. So a couple things to keep in mind when we have a less than or greater than sign, our boundary is going to be a dashed line. Our boundary is going to be dashed. Now if we have a less than or equal to or a greater than or equal to, our boundary will be solid. Alright, so I'll show you what that means. So in our first example we have y is less than or equal to x plus 4. So keeping in mind less than or equal to right here, that's going to mean we have a solid boundary line. But let's graph what that looks like. So again, if we were graphing a line, this would be starting at 4. Our y-intercept is 4. And because there's no number here, it's an invisible 1. And 1 as a fraction is 1 over 1. So from this point I rise 1, run 1. Rise 1, run 1. If you want to get fancy, you could go down to the left. And remember, our boundary line here is going to be solid because we have a line underneath it because of the equal sign. So let's draw our solid line. Now to tell which side of the line we shade, we're going to substitute a point. Now the easiest point to substitute is 0, 0. We're going to substitute whatever side is true. We shade the truth. So if I substitute 0, 0 in, I have 0, which is my y value, is less than or equal to 1 times 0 plus 4. Now I know 1 times 0 is 0, 0 plus 4 is 4, so the question is 0 less than or equal to 4? Is that true or false? The answer to this is true. So that means since this side is true, I shade this side of my graph. Let's graph the next one. Y is greater than 2x plus 1. So again, my starting point, my y-intercept is 1, and my slope is 2 over 1. So rise 2, run 1, rise 2, run 1. Now this does not have an equal under it, so it's going to be a dashed boundary line. And again, I can test 0, 0 as long as it's not on the line. So we're going to test 0, 0 here. Again, what does that mean? I substitute 0 in for my x and 0 in for my y. So here I have 0 is greater than 2 times 0 plus 1. So 2 times 0 is 0, 0 plus 1 is 1. So the question is 0 greater than 0 plus 1 is 1? Is 0 greater than 1? That is false. 0, 0 is false. So since this side over here is false, we're going to shade the true side. In my next example, I have y is less than negative 3/4 x minus 1. My starting value is negative 1, my y-intercept is negative 1, and my slope is negative 3 over 4. So I'm going to go down 3 and to the right 4. If you want to get fancy, you could go up 3 and to the left 4. Again, this has no line under it, so it's going to be a dashed boundary line. And to test which side of the graph I'm going to shade on it, choose 0, 0, as long as it's not on the line. In this case, 0, 0 is not on the line. So if I substitute 0, 0 and I have 0 is less than negative 3/4 times 0 minus 1. So let's figure out what that would be. 0 is less than negative 3/4 times 0 is 0 minus 1. 0 minus 1 is negative 1. So the question is 0 less than negative 1? That is definitely false. So since this point right here is false, that means everything on this side is false, which means I shade the opposite side of my graph. Next graph, y is greater than or equal to 2x minus 5. Again, my y-intercept is negative 5. My slope is 2 over 1, so rise 2, run 1, rise 2, run 1, and so on and so forth. This inequality has an equal sign, so we're going to make it a solid line. Alright, we can test 0, 0 because it is not on the boundary line. So we'll test 0, 0 to see if it's true. I have 0, greater than or equal to 2 times 0 minus 5. So the question is 0 greater than or equal to 2 times 0 is 0. 0 minus 5 is negative 5. Is 0 greater than or equal to negative 5? That is true. This point right here is true. So since this point is true, everything on this side of the graph, on the side of the line, will be true. Next equation, y is greater than negative 3x plus 4. My y-intercept is 4. My slope is negative 3 over 1, so I down 3 into the right 1, down 3 into the right 1. Again, there's no equal sign under here, so my boundary line will be dashed. And again, I can test 0, 0, so long as it's not on the line. If 0, 0 was on the line, you'd have to choose another point, such as 1, 1, or 2, 2. Those would be the easiest ones. So let's test 0, 0. 0 is greater than negative 3 times 0 plus 4. So let's see if that's true. 0 is greater than negative 3 times 0 is 0. 0 plus 4 is 4. The question is 0 greater than 4? That is definitely false. This point right here is false. So if this point is false, that means everything on this side of the line is false, which means I shade this side of my graph. And our last graph, y is less than negative x, or the opposite of x, plus 2. I start at my y-intercept, which is 2. My slope is negative 1 over 1, so I go down 1 into the right 1, down 1 to the right 1, down 1 to the right 1. My inequality does not have an equal under it, so that means it's a dashed boundary line. Line this up here. And we can test 0, 0 because it's not on the line. So let's substitute 0, 0 in. 0 is less than negative 1 times 0 plus 2. So 0 is less than negative 1 times 0 is 0. 0 plus 2 is 2. So is 0 less than 2? Is that true or false? 0 is definitely less than 2. That's true. Since this point is true, everything on this side of the line will be true. So we can shade this side. Now if you've picked up on something throughout this lesson, I'm going to give a little hint here. We read this inequality less than or equal to. If you notice less than, we're shading underneath the graph. If you look at this graph, we call this inequality greater than. If this was a ladder, and we were standing on top of the ladder, above the ladder would be over here, greater than. Shade this part of the side of the graph. In example number 3, that's read less than. Again, less than is below the graph. Again, number 4 is greater than or equal to. So if this is a ladder, above the ladder would be greater than or equal to, would be that side. Number 5, greater than. Again, if this was a ladder, now the ladder is slanting this way, this would be the greater than side. You'd be on top of the ladder on this side, this would be under the ladder. If you think about leaning a ladder against a building, greater than on this side. And our last example is less than. If this was your ladder, you'd be under the ladder over here, less than.